So in a previous section, we saw that we could use exponential functions to model compound interest if we compounded that interest n times a year. But as we compound more and more often, so as n starts to get really, really big, the formula actually morphs into this continuous compound interest formula. So E is now the base, and E is a number that is approximately 2.72. It's an irrational number, so it just goes on forever. And so we'll always use this as the base for our continuous growth or decay functions. R is still the interest rate in decimal form, and T is still time in years. So example 20 says, you deposit $3,000 in an account with an annual rate of 5%. Find the balance of the account after 3 years. Round your answer to the nearest cent. So if we build the model, we're assuming this is continuous interest. It says we put $3,000 in, then we raised it to a rate of 5%, so that's 0.05, and we want to know the value of the account after 3 years. So if we type this into our calculator, we get $3,485.50. And just like before, if you're being asked to the round to the nearest cent, you need to type this all in one go. You can't break it up or it's not going to give you the correct rate. So then it says, well, when will your account balance be $4,000, assuming no withdrawals are made? Round your answer to the nearest cent. So in order to do this, we're going to use our calculator. We're going to go into our y equals, clear out our previous two formulas. And in y1, I'm going to put this model. So I had $3,000. You actually have an e to the x button. It's right above your ln. So if you do second, there's your e to the x. 0.05x. Then in y2, we want to know when the account has $4,000 in it. So I'm going to go to my window, and I'm going to set this for 10 years, and then I'm going to zoom fit. So there's the account growing, and there's the balance of 4,000. So we're going to find the intersection. First curve, second curve, enter. And we're going to round this to 2 decimal places. So that was a typo. It shouldn't say round to the nearest cent. It should say round to 2 decimal places. So it's 5.753. So this is about 5.575 years. So about 3/4 of the way through the 6th year, you'll get your $4,000. To find the effective yield, we did this before, right? We said it is the actual percentage growth of the account over the year after you've compounded all the interest. So now we just calculate that. It's a lot easier. It's just e to the r minus 1. So what is the EAY for the account? So our interest was being compounded at a rate of 0.05, and if I subtract 1 from that, I get 0.05127. If we convert that to an actual percentage, I get 5.127%. So this means at the end of 1 year, my $3,000 will have actually earned 5.127%, even though the bank was only giving me 5%, because every time they gave me a new interest payment, I made interest on the interest I had already made that year. So your effective rate should always be a little bit higher if you have continuous growth.